This is section 4, rates of change, example 2. So when we're talking about rates of change and we're finding the slope of the secant line, the slope of the tangent line, and this point slope equation of the line, like we are in example 2, don't forget we are going to use these equations. Now, again, the slope of the secant line is just the slope formula. Slope of the tangent line is that thing that we derived. The limit as h approaches 0 of f of x plus h minus f of x all over h. All right, and I'll show you how that works algebraically. And then the point slope equation of a line is just y minus y1 equals m times x minus x1. So you don't have to do anything to that. You just have to find the x value and the y value and the slope, and you're done. Okay, so let's do an example. Example 2. To find the slope of the secant line, we're going to have to use the formula y2 minus y1 over x2 minus x1. So I'm going to say that since 3 is bigger, that's my y2. So I'm going to find f of 3 minus f of 1 over 3 minus 1. And that's the math I'm going to do. Now, of course, you know how to plug things in. When you plug in 3, you're plugging it in for x. So for the sake of just figuring out everything I'm doing, I'm just going to show every step. So we will have 3 squared plus 1 minus, and then I'm going to plug in 1, so we will have 1 squared minus 1 all over 3 minus 1. Well, 3 squared is 9 plus 1 is 10, so we have 10. 1 squared minus 1 is 0, so 10 minus 0 over 2, and 10 over 2 is 5. So the answer is just 5. To find the slope of the tangent line. Now, when you find the slope of the tangent line, or the slope of the secant line, right, I use the formula, so I'm writing down the formula. So we're going to have x equal 2. Now, because this is the first time you've really seen this, I'm going to write it down the general formula first, and then plug in 2. So the general formula is the limit as h approaches 0, and yes, that's an h, of f of x plus h minus f of x all over h. And remember, I'm taking this 2 and plugging it in for x. So I'm going to have the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Now I'm taking 2 plus h and 2 and plugging it into the equation in my problem. So I'm going to have the limit as h approaches 0 of 2 plus h squared plus 1. Okay, so I plugged 2 plus h in for x, just like when I did the slope of the secant line, I plugged in 3 and I plugged in 1. And then I'm going to subtract f of 2, which involves plugging in 2. So I will have 2 squared plus 1 all over h. And now my job is just to simplify and keep simplifying until I get a number. So now we'll simplify. So you have the limit as h approaches 0. Notice I have not stopped writing the limit as h approaches 0, because as I simplify and as I plug things in, it's the limits that are equivalent, not the equations. All right, and you'll see what I mean when I start canceling stuff. So we have 2 plus h squared. Well, that's double distribution. So we have 4 plus 2h plus 2h plus h squared plus 1 minus 2 squared is 4 plus 1 is 5 all over h. Now this is nice because if we look and we try to simplify it, because it looks kind of a lot. So let's look at our numbers. We have 4 plus 1, which is 5, minus 5, which is 0. So these numbers are all going to cancel out. And then I'm going to combine like terms with my h's. So I'm going to have the limit as h approaches 0. We have 2h plus 2h, which is 4h, plus h squared over h. Now, notice there's an h in everything. So I'm going to simplify this as well. And I'm going to get the limit as h approaches 0. Now before I try simplifying it, before I cancel, I'm just going to factor out an h because there's an h in both numerators. So, I'm sorry, in both terms of the numerator. So that's h, and that's 4 plus h over h. Remember, if you take it out, it goes down by 1. Well, hey, look, now those h's cancel. So I have the limit as h approaches 0 of 4 plus h. Now I'm going to take the limit. Now I'm going to plug 0 in for h, which just gives me 4, right? Because 4 plus 0 is 4. And that's it. Now I write the equation of the tangent line. Now I have a point. I have the point 2 and then plug it into the equation. I've actually already done this, but we'll do it again. 2 squared plus 1 is 5. So I have the point 2, 5. And the slope is what I just found in this problem in part B. So it's 4. So if my equation is y minus y1 equals m times x minus x1, I just take the 2 and the 5, right? That goes there, and the 4 is m. So I end up with y minus 5 equal to 4 times x minus 2. That's the answer. That's the equation of the tangent line.